In this video, we'll be looking at recording and calculating probabilities using frequency and probability trees. We'll consider whether events are independent or conditional of each other, and then calculating the probabilities of a sequence of events. Before watching this video, ensure you have a good grasp of probabilities by watching the Probability Foundations video, and also the video on fractional operations, as the processes from those will be used in this video. Let's start off with frequency trees. Here, we've got a question in which 70 people work at a company. We're informed that 52 are male and the rest are female. Of those females, 10 of them drive out of the 45 who drive in total. We're asked to complete the frequency tree and then calculate the probability that a person chosen at random from this company would be female that doesn't drive to work. Firstly, we have the numbers that are given to us in the question. In the frequency tree, the sum of the columns must add up to the total, which in this case is 70. So in that first space, we'll write that. Then, moving to the second column, we're told that 52 of the employees are male. We're also told that 10 out of the 45 who drive to work are female. So we know that 10 of the females who drive to work can be placed here. If 10 out of the 45 who drive are female, we can subtract 10 from 45 to get 35 drivers who are male. Now, let's go back to this second column. If 52 out of the 70 were male, 70 subtract 52 will give us 18 females. Of these 18 females, if 10 of them drive, then we can state that 8 don't drive, and fill that in here. Of the 52 males, if 35 drive, then 17 must not drive, and we can add that here. We're also asked to calculate the probability that a person chosen at random from this company would be a female that doesn't drive. We can see that the number of females who don't drive is 8 out of a possible pool of 70 employees. So we can say that the chance of choosing a female that doesn't drive to work would be 8 over 70. This is a frequency tree, which is where you're dealing with the total numbers that fit a set criteria. These can be used to calculate probabilities, but let's look at a probability tree where the probabilities are added directly onto the branches. In this question, Angie has a bag containing only red and blue marbles. The probability that she chooses a red marble is 2 over 3. She takes one marble at random, makes a note of the colour and replaces it in the bag. She then chooses another at random. We're asked to complete the probability tree and then calculate the probability that both marbles are red, the probability that neither marbles are red, and then calculate the probability that at least one is red. Let's start by labelling these branches either red or blue. As the chance of getting a red marble is 2 over 3, we can write that on this branch to the red marble. If all the possibilities add up to make 1, then the chance of getting a blue marble must be 1 over 3. And we can write that here. It's now very important to recognise that in the question it was stated that after she chooses the marble is returned to the bag. So therefore the probabilities won't change for the second choice. So we can write red and blue at the end of those branches, and the probabilities will stay the same as the first choice, 2 over 3 for red and 1 over 3 for blue. We can write those in here. We've now completed the probability tree and can look to calculate the probabilities requested. The first was the chance that both marbles are red. In order to combine multiple probabilities on a probability tree, we multiply along the branches that would give us the success criteria that we want. So we would go red, red, to get 2 over 3 times 2 over 3 to get 4 over 9, and can say the chance of getting 2 red marbles is 4 over 9. Next, to calculate the probability that neither is red, we should be able to recognise that the chance that neither is red is the same that both are blue, which would mean to take these branches at the bottom, meaning blue, blue, and will give us 1 over 3 times 1 over 3 to give 1 over 9. The chance that neither marble is red will be 1 over 9. Now we're asked to calculate the probability that at least one marble is red. There's two possible methods for this, and I'll show you the longer method first, as it seems to be the most reasonable. We need to consider all the ways that we can achieve our desired outcome or success criteria. If we got 2 red marbles, would this be acceptable? Well, the question states at least 1, so that would work. But are there other pathways to consider? Well, if we got a red, then a blue, that would still be at least 1 red. So we can calculate that probability as 2 over 3 times 1 over 3 and get 2 over 9. We should also consider getting blue and then red, which would be 1 over 3 times 2 over 3 to get 2 over 9. So now we have to combine all these possible successful outcomes. 4 over 9 plus 2 over 9 plus 2 over 9, which will give us 8 over 9, as the probability of getting at least 1 red marble. Now a shortcut. Consider the probability of getting at least 1 red is all the possible outcomes with the exception of getting no reds. If we know that all the outcomes add up to 1, we can calculate this by subtracting that single outcome from the total possibilities to get 8 out of 9. Either method is acceptable, but some questions may only enable you to use this second method due to missing outcomes or unknown factors. Let's look at another question, but this time with differing probabilities for each stage of the tree. Here, we've got Class G, who are competing in 2 events in their school sports day. The chance they will win the netball match will be 3 over 4. The chance they will win the football match will be 4 over 5. We're asked to complete a probability tree with these outcomes, calculate the probability they will win both events, the probability they will win only one, and the probability they will win at least one. It's important to note that they have not stated that the outcome of the first match will affect the outcome of the second match. So we assume that it doesn't. We start to complete the probability by labelling the first set of branches netball and the second set football. The outcomes of the matches are either win or lose, so we place those as the outcomes for each of the matches. The chance of winning the netball match is 3 over 4, so the chance of losing will be 1 minus the probability of winning, which will give us 1 over 4. We can write that on the lower arm. The chance of winning the football is 4 over 5, so the chance of losing the football match would be 1 over 5. And we can write that in for both sets of the football branches, as the outcome of the netball match has no bearing on the outcome of the football match. We've now completed the probability tree. We're asked to calculate the probability they will win both matches, and we can calculate this by multiplying 3 over 4 by 4 over 5 to get 12 over 20. So the probability they will win both matches will be 12 over 20. To calculate the chance they will win only one match can be done by 2 different routes. So we can multiply 3 over 4 by 1 over 5 to get 3 over 20 for this route. The other route would be 1 over 4 times 4 over 5 to get 4 over 20. If we added these 2 together, we'll get 7 over 20. In order to calculate the chance they will win at least one is the same as all the probabilities minus winning none of them, which would be 1 subtract 1 over 20 to get 19 over 20. Both of these examples have dealt with situations where the first outcome does not affect the second. These are called independent events. But there are situations where the first outcome will change the probability of success on the second outcomes. These are called conditional probabilities. Here's a situation that can be termed as a conditional probability. Darren drives to work each day. The probability that he is on time is very dependent on the weather. The probability it is poor weather is 1 out of 10. When it's poor weather, he'll be late 2 out of 5 times. When it's good weather, he'll be late 1 out of 8 times. We're asked to complete the probability tree and calculate the probability that he will be late. Then we have to answer how many days out of 20 that he works in a month will we predict he will be late. The first thing to consider is whether or not the weather will be poor or good. So we'll put those two outcomes at the end of the first set of branches. If the chance there will be poor weather is 1 out of 10, then the chance it will be good weather will be 9 out of 10. We need to calculate whether he will be late in either case, so we can label these branches as either late or on time for both sets of branches. If there is poor weather, then the chance he'll be late will be 2 over 5. So the chance he'll be on time when there's bad weather will be 3 over 5. If there's good weather, the chance he'll be late is 1 over 8. So the chance he'll be on time in good weather will be 7 over 8. We've now completed the probability tree. The next part of the question is to calculate the probability that he'll be late, and there are two branches that will give us this outcome: when there's good weather and when there's poor weather. The probability when there is poor weather will be 1 over 10 multiplied by 2 over 5, which will give us 2 over 50. When there's good weather, the probability will be the product of 9 over 10 and 1 over 8, which will give us 9 over 80. If we add these together, we get 61 over 400, which you may want to turn into a decimal of 0.1525. So it looks like just over 15% of the time. This is going to be the overall probability that he'll be late. Now we're asked how many times out of the 20 work days that he'll be late. And we can use the probability that we've just worked out, multiply it by 20 to predict that. We'll multiply 20 by 0.1525 to get 3.05. So he'll be late roughly 3 days in the month. So the answer to the question is that we predict he will be late 3 days in that month. Here we have a similar question to the one before with Angie and the bag of marbles. Now we're told that she has 7 red and 3 blue marbles in a bag. She takes one marble at random, notes the colour, but does not put it back in the bag. She then chooses another at random. We're asked to complete a probability tree to show the chances of the outcomes. The probability of choosing a red marble will be 7 out of 10, and a blue marble will be 3 out of 10, as there are 10 marbles in total. As the ball is not replaced, we need to change the amounts for the second set of probabilities. If a red marble is chosen first, then there will only be 6 red marbles left out of a possible 9 marbles. There will still be 3 blue marbles, so the probability of choosing a blue marble on the second time will now be 3 out of 9. If a blue marble is chosen in the first pick, then there will still be 7 red marbles out of a possible total of 9 marbles. There will now only be 2 blue marbles out of the 9, and this will be the probability of choosing a second blue marble. The probability tree is now complete. To calculate the probability of choosing 2 red marbles will be 7 over 10 times 6 over 9, which will give us 42 over 90. To calculate the probability that neither is red will be the same as both being blue, which will be 3 over 10 times 2 over 9, which will give us 6 over 90. The probability that at least one is red would therefore be all the probabilities, which will equal 1, minus the 6 over 90 for choosing 2 blue marbles. This will give us 84 over 90. In this video, we calculated the probabilities of multiple events using frequency and probability trees. We looked to see if the first outcome affects the second, in which case it would be considered conditional, and we'd need to look at calculating how the probabilities differ in the second set of branches. In the next video, we'll be looking at Venn diagrams and their notations. I'll see you then.